Okay, so welcome back, ladies and gentlemen. So we go through the question. Now, projectile. Okay, the projectile without air resistance. First, activity 1, throwing horizontal. A boy throws a ball so that it lifts his hand 2 meters above the ground, traveling horizontally with an initial velocity of 10 ms negative 1. First, sketch the path that you would expect the ball to follow as it moves through the air. So that means that first question, once we throw, it will move in a path of curve. For the question 1, that means that how is the path? So the path will be a curve. That means that it will move with a curve like that. So we draw. Okay, something like that. And next, question number 2. What is the initial vertical component of the ball velocity? And C, what is its acceleration going downwards? D, how far when the ball hits the ground? And E, the magnitude of the resultant velocity when the ball hit the ground at and with what angle? So now, class, we consider the motion. The motion is a curved path, right? That means that when we throw out an object, when I throw out the object with a velocity of how much just now? 2 meters above the ground with 10 ms negative 1. 10 ms negative 1. And this object is 2 meters above the ground. 2 meters. So this object, let's say it will move in this path. Okay, in a horizontal path. So first, initially, what will be the, okay, there will always be a acceleration, right? So the acceleration or the velocity. Let's say when the object falling down, the velocity initial is 0 or consider it's very small. That means the velocity will increase. But no matter how, this always 10 ms negative 1. When it reaches to the ground, the horizontal component velocity still 10 ms negative 1. Okay, now let's say the object. What will be the acceleration? The object always have an acceleration of g equal to 9.81 ms negative 2. Okay, for this part also 9.81, 9.81. Initially, what is the speed. Let's say what is the Vy? V at 1, V1y, V2y, and V3y. That means in the vertical part. V initially, okay, B initially should be 0 ms -1 because now when we throw out the vertical component is 0. And what will be the acceleration? The acceleration will be 9.81 ms -2. Okay, we solve the question B and C. Question D, how far when the ball hit the ground? So first, that means that we know that the time, find out the time taken first. So from here, by using S equal to U T plus 1/2, okay, AT squared. Now I want to find the vertical component. That means in Y. Sy is equal to Uy. T, time taken for all are equal. Plus 1/2 AT squared. Okay, now when we throw out an object, with 10 ms -1, let's say the question just now said that, okay, we look at the question, back to the question. You see, throwing horizontally, right? But projectile without air resistance. If no resistance, no air resistance, that means that when we throw out an object horizontally, the horizontal component are always constant because there is no air resistance, no other effect that reduce or affect the speed or the velocity. So that means that horizontal components are always constant. Going downwards is affected by the gravity. So gravitational force will cause the difference. Okay, now I want to find the Y in Y component. Sy, as we know that the height is 2 meters. 2 meters initially is 0 T plus 1/2. When falling down, the acceleration is 9.81 T squared. So from here, what will be the T? The T, I get that. If like that, that means that, okay, T is equal to 4 times 4 divided by 9.81. That means I will get that it will be 0.64 seconds. Okay, so that means that the time taken is equal to 0.64 seconds. D, we want to find the sorry, let me see what is the question want us to find what? The how far when the ball hit the ground. Okay, that means that we want to find out how far, right? So what is the S? Okay, how far? That means that the X from the X component. That means that initially fall up, that means from here to here, what will be the X? The X is for X. The time taken to fall down is equal to the time to reach this part. Okay, the time taken to fall down actually same with the time to reach this part. So that means that S displacement is equal to Vx t. Okay, if I set that Fx, Vx, Tx, hey, the Tx equal to Ty, right? So time taken for the Y component and the time taken for the X component are equal. So that means X is equal to Vx. What is the Vx in the horizontal component is always 10, right? So at this point, when it reached here, it's still 10 times with the time here. This point, the time, what is the time? Time is 0.64 seconds. So it will be equal to 0.64 seconds. So that means Sx is equal to 6.4 meter. So that means that the distance, once we draw horizontal distance, xx, the distance will be equal to 6.4 meter. Okay, now we want to find out. I change the color. We want to find out the V when it reached the ground. Okay, so for this part, what is the VR? So E, there will be a this ball with 10 ms -1 for horizontal. Vertical, what is the maximum speed? And this will be VR. What we need to find out the Vy first. So I use the formula. That means that when it's here, maximum, U is equal to Uy equal to 0 ms -1. What is the Vy when reach the ground? Falling down with G equal to 9.81 ms -2. And the time taken T is equal to 0.64 seconds. So that means that V, by using formula of Batu, Vy equal to Uy plus AT GT. So Vy is equal to 0 plus 9.81 times with 0.64. Okay. So how much I get? 9.81. That means that 0.64, where the Vy is equal to 6.2 at ms -1. Now this equal to 6.21, sorry, 2 at ms -1. What is the VR? Okay, let's say I give an angle like that, the direction. So now by using the vector method, we solve it by using the vector method. VR squared equal to Vy squared plus with Vx squared. So VR squared is equal to Vy 6.2 x squared plus with 10 squared. So VR is equal to how much? We get that is around 11.8 ms -1. That means that this will be when it reached to the ground. The resultant velocity is 11.8 ms -1. And next, find out the angle. What will be the angle? The angle is like that, right? This is the angle, right? So this is 10, right? Sorry, this is 10. And going downwards is 6.28. So I use 10. 10 delta equal to 6.28 over 10. So delta is equal to how much? So this means that angle shift 10, 0.628. I get that the angle is equal to 32.13 degree. Okay, so this means that I can set that what is the resultant velocity? The velocity okay, 6.11 at ms-1 with 32.13 degree from horizontal surface. This means that we explain the direction. The magnitude of the resultant velocity and the ball. Okay, and when the ball hit the ground and with what angle? Okay, so this means I get the answer already. Okay, question number 2. A girl hit a ball horizontally with a tennis racket. The ball is 2.5 meters above the ground when it leaves the racket. How long will it take to reach the ground? So acceleration due to the gravity is 9.81 ms-2. So this means that the girl hit the ball, okay, 2.5 meter. Okay, for the question number 2. A girl hit the ball where the ball lift. We don't know how much is the Vx, but we know that it is 2.5 above the ground. So that means that the ball will move in this motion, right? This direction, right? Okay. So what is the time will it take to reach the ground? So that means that as we know that uy equal to 0 ms-1, vy is maximum, right? Okay. Vy we don't know. Sy is equal to 2.5 meter. A is equal to 9.81 ms-2. And what is the t? We want to find out the time taken. So that means don't use any equation with v. So SATU. S equal to Sy equal to U YT plus 1 over 2AT squared. S is 2.5 equal to U0 times T plus 1 over 2 9.81 times with T squared. So at the end, we solve it. The T we get that will be 0.71 second. Okay, get it? This is for the object that we throw out horizontally and it moves with a curved path. This just half of the parabolic motion. Okay. Now another type of projectile motion. Okay. Let's go to let's look at the motion. Okay, we directly go to the path and track. When the object throw up with 30 degrees, let's say the initial velocity is 5. Once I throw, okay, very small. Okay, better I throw with 25. We notice that. Okay, if I throw with 25 ms -1, the speed, what happened with the same angle I increase the speed? Once the speed increase with the same angle, that means that the object will move further. Same thing with the same distance. Once let's say I throw with a small angle, 15 degrees. After that, I throw with 30 degrees. Okay, then I throw with 45 degrees. Okay, after that, okay, I increase and increase, right? After that, I throw, okay, look at the distance, yeah, 160 something, yeah. Okay, after 45, I throw with 60 degrees. We notice that the distance reduced, right? But the height increased. Okay, what happened if I throw with, let's say, at t degree? At t degree. That means that when the distance become nearer, the height become higher. If I throw with 90 degree, what happened? That means throw upwards and downwards. Okay. Now let's say I throw with 45 degree. 45 will be the maximum. Okay. 45 will be the maximum angle. Okay. I throw with 45, that's mean maximum angle. Okay, this angle with maximum distance. Okay, after 45, let's say 50 less. Okay, so now I use 45 degree so that I get the maximum distance. How is the force? The force going down are always equal. The velocity, now the object, the velocity upward, after that none, so downward when falling down. Always with a resultant velocity. Acceleration are always shown downwards. Ladies and gentlemen, this we need to remember that here will be the maximum distance. The maximum height will be here. Okay. Another thing is the time taken from here to here. The T up is equal to the time to fall down. Okay, that means T up is equal to T down. That means that time of flight, that means throw up time of flight is equal to 2T. If this is the time taken to reach the maximum height. Okay, so we assume that distance up and distance down are equal. Okay, one thing. So no matter how the G is always 9.81 ms negative 2. So now, ladies and gentlemen, we go to the question. Second question for the projectile motion. A ball is fired into the air at an angle of 30 degrees to the horizontal. Sketch the path it will follow through the air. B. At which point is in its journey is it traveling most slowly? C. State two ways in which the ball would be made to travel further. Okay, two ways. So if its initial velocity is 14.7 ms/1, how long will it take to return to the ground? Acceleration due to gravity is 9.81 ms-1. Okay, let me share to the words file. Now, question activity 2.1a. The path of the motion okay, something like that. Okay, A. Then question B. At which point in its journey it is traveling most slowly? Okay, at which point of its journey is traveling at the most slowly? Mana satu titik dia adalah paling lambat. At which point it is the slowest? So B. So at the maximum height. Why at the maximum height it will be the most slowly? Now we look at here. If this is the motion, okay, once we throw out, we must know that if I throw out with a, let's say, v velocity, that means that these two things we must consider the angle. Okay, let's say I give a this, let's say it is a v. That means that this will be vx, this will be vy. In the time of flight, always the vx, 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 vx always constant. As just now what I explained, the x component always constant because without any air resistance. None of any effect. But why? Here vy at position 1, at position 2, and at position 3. Vy1 is equal to 0 ms-1. Sorry, not the v. Initially we throw out, that means that it will be maximum. Vy1 is maximum. Vy3 is equal to 0 ms negative 1. Why? Because at maximum height. Okay. Now, what will be the Vy2? Vy2 and Vy3, Vy1, this will be the relationship. Okay. And Y3 at the maximum height, the vertical component will be maximum. After that, how about V4 and V5? Okay. So V5 come back again. V5 will be equal to maximum ms negative 1 again. What we learned just now, that means that we learned the left part just now. Now we are going from left part to right part. Okay, so back to the question numbers. Okay, in this case, we must understand one thing. When we throw out an object, let's say, an object we throw like that with a velocity, this will be the Vx and this will be the Vy. Okay, and this will be the angle. So from here, this Vx, as we know that Vx is equal to V cos delta. Vy equal to V sin delta. For upward, what we use, V equal to U plus GT. Where V, Y, U, Y equal to G, where this G, because we throw out, is against the gravity. Okay, V equal to U plus AT. So this one, Vy squared equal to U Y squared plus 2 negative G S distance. And S Y equal to UYT plus 1 over 2 negative G T squared. And S Y equal to 1 over 2 UY plus VY times with T. So these are the formula we use if I use Y. Okay, so that means it's more easier for us to remember this thing. Why? Because if I put in the sin delta, cos delta, turning already. Okay, before that, the basic we use this one. If we want to find the X, Vx, if use any Vx, okay, Vx, what we will use, that means that we use it to find the range. Okay, the range, the distance. Okay, the R is equal to V times Vx times with T flight. The time taken of the flight, that's all. Okay, so just now, back to the question just now, why we said that at the maximum height it will be the slowest. At maximum height, that means that the object just have the Vx only. Okay, so it just have and the Vy is equal to 0 ms negative 1. So that means that the resultant force Vr is only equal to Vx. Okay, at others position, they will others position, okay, others position either they will be a force like that, Vx, Vy, or here Vy, Vx. That means that it will have a Vr. This will have Vr, where the Vr is equal to Vx plus Vy, the vector. Okay, so that means they have two components. That means it's faster, but at the maximum position, Vr, vector of Vr is equal to Vx only, without another component. So we said that it is the slowest. Okay, ladies and gentlemen. For the next question, B. Okay, already see. State two ways in which the ball could be made to travel further. So two ways. What is the method to make it travel further? That means that first, increase the projection. Okay, that means that increase the speed when we throw up. Second, okay, use 45 degree of projection. That means we project with 45 degree. More than 45 or less than 45, okay, that means that will less. Why? Because you see, sin 45 is equal to cos 45 degree. No matter how, here in this case, if like that, right? We want to find out Vy and Vx. So that means this will be delta. Okay, so we want to get the maximum. That means that only the degree equal to 45 degree.